Okay, so now we can start. So my name is Michael Chumakin, and the topic is here on the board, which is anthropology for social activists. Anthropology because the topic is pretty wide, but most of the disciplines it covers is related to human and disciplines that study the human. So it's sociology, psychology, economics, politology, and anything you can think of is in linguistics. This or that way it's connected. But it's part of this, part of that, so in a short umbrella word it can be anthropology. The other thing is that I think I am targeting people who want to induce some change in this world, a social change. Well, I've been googling the word change, so it has like a lot of mentioning, so it's a buzzword. But I do not see anybody doing a good, nice, or targeted change in the world. So we have the government research facility, CG, right here. There is like a huge, Perimeter Institute, 2 universities, the biggest college in Canada, all here in one small city, and we cannot say, okay, this change in our city was done due to the research done by the scientists from this facility. No. And there is a lot of theory. My idea is that to look at the theory and find the places that we can practically use in our attempt in changing this world. Well, the test of the theory is in its practice, and I believe there are some instances that we can use. So I put down the pros and cons of this topic. So one of the pros is, there is about 15 of them. So just to bring together most of the knowledge we have access to so that we can use it in our social activity. On the other hand, we already know a lot of facts, and what we need is to bring them into a mosaic. So a picture that makes sense as opposed to a kaleidoscope where you just turn it a little bit and it changes completely, and there is no connection between one fact and the other. Then, of course, the theory is supposed to give a plan of action for the people who use it, so they can understand and predict social events in the community, in the country, and in the world. And to do all of that on a solid scientific base. And that includes worldviews, a lot of intellectual implements, and real-life practices. On the other hand, there are so many activists, and they have different views, different approaches. And these are lectures, if you know each other better, you might get on one and the same page. That will help acting together, coordinated. And so there is one part of the course that is about a theory of governing anything, from a small team of people to a state. So there are some general rules of how a group of people can be directed, controlled, governed, guided, whatever you want. On the other hand, I am bringing up a lot of knowledge that has been forgotten. It's 19th, 20th century stuff. People already went through all of that, and new generations of activists reinvent the bicycle. So they do the same stuff again and again. They have to think over. Now with a ready-made knowledge, so you can save a lot of time and keep like into the advanced thinking edge. Well, then, so that's for listeners. There is a game for community, so that community will probably see your projects in life. So that is a good thing, I guess, because you are thinking of something good, right? Don't you? About myself, for myself, it is bringing together and taking into a system a lot of the views that I'm talking about. For me, it is, I would say, step number 3. So the second, well, I was just collecting then, a year ago in January 2017, I published this book. It is in Russian. By the way, you can take this, and on the list of reference, on the top, there is, oh here, one more, the ISBN of that book. So I'm not writing that Cyrillics here, it's just, there is a book, and most of what I'm talking about is already in that book, so I'll just bring that into speaking mode. At the same time, on line above the book ISBN, there is a address for thinkingtoolslivejournal.com. I started that community where I post anything about thinking tools, and a lot of my activity in that area. Most of the posts there are in Russian, some of them are in English. Just look for the tag English and you will see them. More things about what bad sides can this plan bring, and I was thinking of 2 things. Of course, you waste your time, so you spend your time, you have to commit your time to come here, thank you for that, and that's, you don't do something else. And on the other hand, I was thinking, okay, I'm going to tell you some bad news about real life, and that may upset you, but because you're activists who have some concerns already, so that might be the reverse. So by listening here, you will find solutions to the concerns you have and see how we can resolve them. The other, well, yes, I will be referring to this references list all the time. On the top, there is a link to the International Association for Ontology and its applications. The association is full of people from IT industry, so their definition of an ontology is a little bit different from what I have here on this paper. So it's a branch of metaphysics or philosophy dealing with the nature of being, and a set of concepts. And basically we'll be talking about like the very basis of that, first of all, which is easier because the basics are usually common sense and quite understandable. There is no rocket science there. But as the word, it will be in use like a lot, and I would refer to that ontology as the set of ideas of understanding what is stuff made of, how we relate to each other, how the society works. It can be quite ideas that we all share or we even are not aware of, but they can be calculated if we just go into deep analysis of what you have in mind. And this is why I was going to ask you to bring in a social project. And if you don't mind, just you can email me or put it somewhere in the thinking tools as a comment. So what is that? And my plan is to compare what you think of this project now and what will change in your understanding of this project at the end. And that's approximately 3 or 4 meetings more. So that's a request, and now, after I weighed all pros and contras, pros overweigh a lot. So I think we should be okay to continue. Okay, yes, we'll keep it. All right. Now, to the approach. So how I'm going to view and present you all this stuff. And my, well, let's try to do this. So say there is a real life object we have, and we want to see it like a scientific way. So what we do that Cartesian graph coordinate and how it's projected on it. So if you look from this side, so that will be the projection of our real life object on the scientific screen. So which is true, but if we add one more plane and project it on this way, so we shall see something like that. So that is another projection, a scientific projection of the same object done according to all the scientific rules, and we have another true picture, and that would be number 2, so that will be number 1. And still we know we have that object that is in the middle of them. So the question is, so that is scientific, that is like common sense. Which is true? Where is the truth? What is science going to tell us, or anything else? So my answer is that we have to consider all the projections and that as well. So, okay, that is scientific and that is scientific with another discipline, another point of view, that is another approach, and we have to consider all of them. If you came across technical drawing, you know that they have a 3D drawing, right, and 2D projections of the plane. But here we usually have some invisible parts, and it's also we usually show that on the picture, right? What is there inside? So we can include these 3 plus the inside, and that would be not enough. We would love to know what material is it made of. So add it like 5th dimension, so to say, and that is not enough. We would love to know how it's manufactured, the process it takes. So if it is metal, is it poured or stamped or rolled or bent or somehow somewhere else? So there are a lot of technologies how to deal with metal or plastic or whatever material it is. So all these combined, the more material we can get, the better. So what I'm saying, when I'm talking about approaches, I would love to encourage you, yes, we are looking at scientific ways, but there are other approaches, there are other views, and as soon as we know them, we cannot ignore them, and we shouldn't. Well, there are a lot of artifacts on our planet that are dated like 1,000 years old. But there is no technology known to us now, and we cannot replicate them. There are skulls made of crystal, so it's processed in a way that we cannot do now. We probably aren't capable to repeat the pyramids, like the biggest of them, with 2 million tons of material in there. There are some huge blocks of stone everywhere. So there used to be technologies, and Now we know for sure there was no science, because science is something born now. How come they did something that we cannot do without science? So they did. So that way I would love to say, yes, science is good. Due to science we have all these buildings, light and warm air inside, thanks to science, all the gadgets. Yet there is something that is not covered by science and cannot be. And we'll go there, but before we go there, we have to find out about science as much as we can. So, like, what is science? So this is another topic. And if we view science, first of all, as a social phenomenon, right now it's an industry. There are institutes, research and development places where people are paid for doing science, laboratories, tests. There is a bigger process. So a lot of money is infused into just research. It's a huge part of our life. It's an industry. And science is traditionally, on the social part, is divided into academic and applied. So the academic at Perimeter Institute, applied at the Waterloo Engineering Department. So when they learn how to use all these knowledges and to make bridges and gadgets and everything else. One of the names I put down here was Paul Feyerabend, so that's at the bottom of the page, on the first page of reference. And he wrote Against Method Outline of Anarchist Theory of Knowledge, first published in 1975. So he is one of the most famous philosophers of science. And the essence of the book, he's saying that any kind of nonsense can be called science. So he researched a lot of things, books, stuff, and he could not find anything that can unify and show what is the common basis for all which is traditionally called science in this world. He says anything can go. And that means that from the social point of view, from the societal point of view, society can call science anything. So that doesn't give us a clue. Still, we want the answer. What do we call science? What are the signs of science? So that way we go into the epistemological part of looking at science. Epistemology, epistema is knowledge in Greek, logi is logical discourse, logos, so epistemology. From that point of view, so science, and as anything else, it's as any approach as philosophy and other stuff, they consist of ontologies. And ontology is a pretty wide definition. So there are axioms, laws of nature, a lot of other stuff. So it's just idea how things are done. We will, at one point, we will go deep into that, so that to have samples of what ontology is. But as examples, does God exist or not? This is an ontological question. Then there is an object that is in view, and there are thinking patterns that are used together with this set. I'll call them intellectual implements, and that will stand for II. So that's shorter. And now, how to discern what is the ontology of real science and the object they study and what the intellectual implements. To do that, I refer to a list of the thinkers who are at the base of science. So I started with Francis Bacon. It's just in chronological order there. He is the youngest among all of them. He introduced the word induction into use, and he was arguing against Aristotle's organon. So he wrote his new organon, where he defended his new method, saying that we have to observe facts first of all, and then induce our theories from them. And it's supposed that Aristotle said that we have to have general concept ideas, and based on them we have to deduct how the world is done and what we can do in that. And he called himself a science propagandist. So he was promoting the idea of science and it will save the world and things like that. Galileo Galilei, an Italian guy, he found the phenomenon of acceleration. So he was born in Pisa, not far away from that Pisa tower, which is bent. And what he did, he was rolling metal balls down that Pisa, so they were going, and he was measuring the speed, the distance, and the relation between them. And he found out that all of a sudden the balls started to accelerate. So he found that ratio and wrote about that. He also did a lot of with telescopes. So he actually introduced experiment, described it, and set up a pattern of doing experimental work. So, and based on that experiments, he made that notion of acceleration. Everybody agreed to that. So there were trials, and that is setting up scientific procedures, which is important. René Descartes, probably I will say Descartes. All right. There is one work mentioned here, Discourse on the Method of Rightly Conducting One's Reason and Seeking Truth in the Science. Well, all of these numbers and ideas are according to traditional history, which are very questionable, because they only basically discourse on the method of rightly conducting and things like that is his only work. It's only 32 pages, and yet he's said to be have introduced algebra, ABC, XYZ notation, that coordinate graph, analytical geometry, many other stuff. Most of his work is letters, appendices, not published, just pieces of paper left here and there. And that, as a researcher in science, that gives me a doubt whether he was the author of that. But anyway, so they say so. Let's follow by that traditional view. Now, John Locke. So he was the author of this famous tabula rasa. So that is a clean board in Latin, means that the person, a human, is born without any knowledge. Anything that we get, people receive through social contacts, through society. So that's empiricism. Everything is, whatever is in our mind comes from our experience with the world. Isaac Newton, so he is here because he gave birth to the 3 laws of mechanics, and he is supposed to be the father of gravitation, but a lot of doubt with that as well. But anyway, he wrote a lot about that. He made several works in optics and the gravitation and physical laws associated with Isaac Newton. Carl Linné, a Sweden guy, he was the father of taxonomy. So he was the one who thought of those two Latin words that will define any living plant or organism. Well, so these are the basics. Now, if we look back at what they talked about, what they considered, what they researched, so we can get an idea of what they thought the world was made of and what was the object of their research. And if we read carefully them, so they were, most of them, like looked at the world as made of atoms. And like the irony is that most of them were deeply religious people, but for their physical laws they didn't need the presence of God. So that contradiction a little bit in what they did in science and what they did in their everyday life. So the object, well, for me, I would say that Galileo's metal ball would be the best if we visualize that object, it would be something like that. Something that we can see, we can touch, we can weigh with our human perception without any special instruments. So that kind of an object. And with what kind of thinking tools they have been using. And I gave a list of those tools. I think it should be somewhere. Okay.
Line here, or are you looking for a reference?
Somewhere in the reference.
What you're looking for?
Yes. My paper doesn't have. Yes, observation, hypothesis, theory. Yes. So first, well, can I take this paper, please? Thank you. Yeah, not on my plan. So first of all, we observe the facts. Then we induce a hypothesis. And if it turns out to be true, it is called theory. Now, the part of the theory is a model. So it's just a more compact expression of that theory. They use mathematics, algebra, and formal logic. Well, to prove the theory, they use experiments. There are a lot of procedures, and all the facts come as a system, a taxonomy. So all these stuff is was born, was nurtured, was brought up thanks to all these activities of all these people and everybody else who followed science and scientific. So this includes all scientific, major scientific mental instruments. One of them is not mentioned, and I will talk about that later. But so that looks like the way it is. So I'm not inventing anything here. Right. So we talked about science from the point of view of epistemology. So it has its own ontology, object, and thinking tools. There is one well, our object here, that what Newton, Galilei, and others researched, is something that we can touch, see, and feel with our senses. And that brings up such a thing as that there are three different levels of object that current physics researches. So the one that we can touch, feel, and with our own eyes, I would call macro. There is also a micro world and mega. For me, what is important is that if we go into micro world, that means electrons, positrons, bosons, and all that stuff. Nobody have ever seen them or touched them. So they are all completely invented, thought of, something untouchable, invisible, and people argue about them. So there are people that say yes they are, that they are not. So in that way, so this micro object is not the same as macro. They're different. And with mega as well. With our real life objects, we sure it has gravity, and we can demonstrate it right here. With mega, asteroids and comets do not have gravity. It's proven. So some of the laws of the nature that are here do not exist here. Some of the laws of nature that exist here, like we cannot put together two electrons without a nuclear explosion or something like that. That means that I would refer to regular science only the one that researches this real life stuff that we can see and touch ourselves. Why I do that? Because if we go into different types of objects, our thinking tools will change as well. For example, with micro electrons and smaller particles, there is so-called Heidelberger uncertainty principle, which means, so here the person does not affect anything. Object is objective, it is there, it is eternal, it is solid. It doesn't matter I am there or I am not, or anybody. So it doesn't depend on any mind at all, on any human. With micro it does. So if there is an observer, they start to behave differently according to that Heidelberg principle. Again, as I noticed, with mega stuff, gravitation is under question. There is more. I'm not a physicist. Just I know some, just little bits, but it is enough for me to say. So let's think, and what I will refer to as a scientific object, something of that kind. Only macro stuff. And that will help us keep up with the thinking tools, because otherwise there is a lot of change and it's difficult to follow them. Anyway, usually, well, metaphysics, they think of ontology and object. And people used to believe that there are universal thinking rules that are true, doesn't matter what we are thinking about, which I do not agree to, and I would love to talk about that. But just before we start talking about that, I would love to summarize and to kind of give more definitions to these thinking tools and what we are doing. So what is science? René Descartes, in his discourse on the method, he suggested that we shall start talking about a world around us from scratch. So use common sense, and then he induces some rules. One of them is going from complex stuff to more simple. So reduct stuff, make it simpler, break down in parts, and then look at the parts one by one. So this simplification is a very important feature and principle and notion that science uses. Let us simplify. Okay, we have some complex objects. Let's break it down into parts and then consider part by one by one. That's one idea. So reduction, simplification, going step by step, following procedures. You cannot. So if I set up experiment in that way, you want to repeat it, you have to be very careful in doing that step by step again. I think there used to be, yes, a list of words. Thoroughly and truly, meticulously, accurately, scrupulously, point device, accurately. So these all things are associated with what science does. If we in that area, so we are trying to do this. One of the very important parts of science is modeling using math and logic. I wrote down the name of Charles Percy Snow. He delivered his lecture in 1959, The Two Cultures and the Scientific Revolution. So the guy here describes two societies. There are humanists and, humanitarians, the linguists and such, and those who are mathematicians and physicists. And he noticed that when there is a conference, when there are humanitarians and physicists, physicists will talk to each other across a humanitarian without noticing and giving any attention to that person, like ignoring them completely. So myself, I've been participating in a lot of scientific forums, and oh, you're humanitarian, I just don't talk to you. You cannot say nothing good, it's all garbage that you're saying. And there is something with the way they're thinking that brings them to that, and I want to talk about that. So using math, if you're not using mathematics, you do not have formula, you're not scientific. Formal logic, it was brought up to public within the university engineering courses. So any good engineer is very well versed in formal logic. And of course, they're making up models. One thing about models are, so what is a model? Model is not reality. It's approximation, they call it. So technically, model is never, so it's always not the same as the original. So technically, I would say scientists deal with invented things, and based on those invented things, they are able to act in real life in the right way. And here we can think of how that happens. So people have something in mind, like the graph I had here with that object in the middle and that projections. it doesn't look nothing real, so it's a very rude kind of, but in our thinking, we start relating that very rude picture to something that we find completely in our life. So what I'm saying, so scientists make models and then they apply a certain intellectual effort that allows them to go to, so there is some intellectual implement used here, and then it comes to real life and they start relating parts of that model to real life using that tool. And that tool is never mentioned as the set of tools used for thinking in science. But without it, an engineer cannot, or workers and production people cannot make a gadget out of a drawing. So they have to do this step, all of them, all of us. So what I'm saying is that we have to say, well, name this somehow. We'll probably will try to do it later. But for me, there is that step that has to be mentioned and pay attention to. Now, so this is in engineering. So we have a drawing, we make an effort, and we relate it to real life. Similar stuff happens in humanitarian area. So they also have some kind of understanding of models, and they try to relate to real life. In my view, their models are not so in a way it's before we do a model we have to invent that model out from real life first, right? So that's model, then we go back to changing that real life. When a humanitarian does that, they do not see real life in the right way, because all these humanitarian sciences like history, sociology, psychology are so much loaded with all political correctness and whatever, that they do not call the spade a spade, and there is a lot of other stuff and a lot of contradictions that they do not start from real life. That's my view on that. But as a result, they have models and they have suggestions that engineers laugh at. But this is where the prediction lies, I guess. Anyway, so we need to find the ways to reflect life and make a model of it in the correct scientific way. And based on that model, we can plan our actions so that they will affect real life in the real way. What are other examples of that intellectual effort? Well, engineers, for example, have to solve a problem. For example, make a new type of a curtain, or something like that. So some construction change, it can be rolled, it can be curved, it can be taken aside, it can be striped. So when they have the real life problem, they start to looking into that and breaking it down, simplifying that into parts and saying, okay, what is that? So what they do on their way to the model, they start categorizing. So they start think of categories. Okay, this is not curtain, this is a plane, this is fiberglass, this is plastic. So they, from real life objects, they come to separate planes and they have to name them. And this effort is also similar to that. So what is this? Is a dry erase marker, but we can say it's a pen, right? So, and that way that we understand what we are talking about, if we call it different, or it's a drawing instrument, yes, a drawing instrument. That's why we categorized this concrete thing into a drawing, and then, okay, we deal with that category and think with that, so then we build up a model. This effort, when we do look into the things and find what they are in real life, is what Aristotle and other stuff worked. That's what was denied by Francis Bacon and other stuff, and it's called reflection. Reflection. Now, there is, well, there is a number of meanings, of course. In philosophy, reflection is to reflect, to think upon, but I told a couple of you guys there used to be a Moscow methodological circle, and when it comes to the Russian language, they used reflection. So in Russian it's pronounced as the reflexiya, and that reflexiya in its traditional philosophical use, reflexiya used to have stress here, reflexia, and that is like a wide philosophical term. That Moscow methodological circle changed the stress and started to pronounce it reflexia, and that is their own term that describes this effort of a human to look into the depth of the things and to understand what it is like as a concept, as a category. So in English, I don't think we can change the stress or anything like that, just reflection in the meaning that it is an effort to see the depth of the things. And with that reflection stuff, it's so basically I would say there are two major types of thinking effort. So if you look from a point of view of a person, so once we go step by step, stupidly correct, without going aside and trying to be as consistent as we can. So that is one way of doing science, and a very important one. At the same time, we cannot avoid this without reflection, without looking into the depth. We cannot build our models and then relate it to real life. So I would say at this moment, let's think of two major kind of efforts we do, and basically this reflection thing we'll be using as a term, as a tool on our next, well, anywhere else, so we'll do reflection. So after you come home, I will post this video, you can look at that and maybe even listen to that again, so that you can reflect, think, and give some feedback. As they say, it is very good to read, but one also needs time to reflect. So sit down and think over what has happened and what it means. like Justin, what is our Prime Minister? Trudeau. He is the Prime Minister. What does that mean to the country? Why was he elected? It's not only just the votes. Why did he come to the surface? Why he was able to go through all this process? So this is a reflection that we need to do, and just to see beyond his own wish, and his wife told him, go and we have good money or something like that. There are some differences, so we have to reflect on that. And that kind of reflection that we use in our deep thinking and our analysis, that's what we need. Now I will get into the end of the first part, and it is almost an hour we've been. So I'm planning a break, and let's come back in about 5-7 minutes. Any smokers? No. Science gave us some tools to think about, and now we have to know how to use this knowledge in social projects. But it will be much more later. Well, just to finish off with social aspects of science and scientific thinking. So I talk about snow. Now there are two more names that I didn't mention. Auguste Comte, a French philosopher known as the founder of sociology and positivism, and Herbert Spencer. So he coined the phrase survival of the fittest. So the birth of science and its help society to progress in technology was so big, so successful, so winning, that the ideas of being procedural, making models, using math, using a formula, won all over the world, and all the educated people were fascinated with this. So this is how Auguste Comte and Herbert Spencer were so well known. Like Spencer published so many copies of all his works. He was so popular immensely. Because people watched the science, they watched the progress science helped to do, and this is the way to go. So what happened at the end of the 19th century with all this positivism is that the thinking with this scientific way of making models, relating them to life, expressing everything in formula and things like that, was so popular that the people, kind of most educated people, engineers, doctors, well, mostly engineers and doctors, they were thinking that the royal or what is that? The society was governed by Tsars, emperors, and royals in the 19th century. British Empire, Austro-Hungarian, Russian Empire, China, India, so they all organized in as monarchies. So monarchies were useless because these educated people understood that we can make a lot of people happy just with this simple stuff. It's just 1, 2, 3. Like, let's do it. The only barrier was the monarchy. So added all the revolutionary ideas, added Marxism and a lot of other people who were against monarchies. Start of the 20th century, monarchies didn't exist anymore, except for the British one. It basically lost its colonial status after the Second World War. But anyway, Europe was clear mostly over all the monarchies. No? Spain?
Sweden, Netherlands, Spain, Belgium.
All right. Yeah.
Monaco.
Okay, let's talk about Russia then, so I know more about it. So monarchy disappeared, and the most people that came to power were scientifically equipped people who were scientists and who were very well aware of all this stuff. What was the question?
Just move from Bob's definitely correct. But to your credit, right? Like there was a big collapse in monarchic power
Yeah.
in comparison of probably.
Yeah, so there's actually government agencies that set up parallel to the monarchy so that the regular governance was done in a democratic manner rather than through an autocratic manner with the monarchies. But you know, the monarchies didn't dissolve, they didn't disappear.
For sure,
they
for
still
sure.
exist.
My next step of thinking is that okay, it's well, I would not blame like Marxism and exploitation stuff for that. I would blame positivism at that kind of applying math to society directly that happened when they studied Soviet Union and they studied German socialism, National Socialism, Italian fascism. In Spain, there was something similar to that. French also were converted as part of Germany. So I would say that people with that kind of thinking won all over the world, most of it, and that brought some big mistakes. So I would blame not their bad kind of, so that they were villains they wanted to have all these murders and death happen. It happened against their will. They wanted to do the best. They wanted to liberate people, but as the result were big wars and a lot of death throughout the first part of the 20th century. I would blame part of that on that applying of scientific methods of thinking directly onto the society. So what I'm saying, it's not the same. There are some differences, and we have to consider them in order not to do anything as bad as happened like 100 years ago. And in that way, so we talked about the object of real good science, and this object in macro world, it is eternal. So it exists and exists and exists, and we so it's solid, eternal, doesn't change.
Sorry, what is that?
The object of the regular science, of macro science, is like a metal ball. If it changes, we can measure the forces change that, and every change can be traced down and measured and wrote down, registered, monitored, and things like that. Otherwise, if no force is applied, it's eternal. On the other thing, it is independent. So it means whether we are there independent or not, it will be there. The same laws will apply to the ball, whether it is Venus or the Sun or the Earth. Then, yeah, so that means independent, and it follows the same laws, and it can be measured in the same way as here, the same way in Washington or in Delhi or anywhere else. One curious stuff, so when we are thinking of these objects, we need a sample of something. We are talking of an average sample. You might have never thought about that, average like that.
ABE.
E here?
Yeah.
All right. Average. well, later on we'll see why it is important. But technically, so we take a sample of 100 species, and we choose one of them because it's the closest to the middle, right? So this is okay. This is the right wall. It's close to the measured mean, mostly close. Not exact, but very close. It's average. Now, if we, and all this is about dead matter. So the classical science, mechanics was doing all the research on dead matter. If it comes to live matter, something alive, that object is different in all these ways. And first of all, it's different in the way that it goes in cycles of life and death. That means that in principle, no organism can live eternally. So there is something very basic with our life at all, that any specific concrete organism cannot exist eternally, and there is no way in trying to search for eternal life. There might be some use in that, of course, but just to make it longer. But philosophically speaking, I think it cannot be achieved because it goes against the principle. And that makes the difference between dead and alive. That is, starts and finishes, that always exists. One more interesting idea. So this is eternal life, so it's solid and does not change. With this death life circle, we started off thinking of an object as constantly changing. So if we think of a butterfly, so is this a butterfly?
Yep.
Okay, butterfly. We have to think of the first is like an egg, then there is a caterpillar, then it turns into cocoon, and then all these are the same object. This is a butterfly, and this is a butterfly, this is a butterfly. But so, and we're still thinking of it as, but it changes every second. It's never the same. So that means the thinking of that cannot be the same as thinking about that. We cannot register that. We may miss that. But when we think of a live thing, we, at the background of our consciousness, might consider that. With a ball, no. And that is one of the basic things that is within how we approach a live object and a dead object. So constantly changing and goes into life and the death cycles, still for our understanding, it's one and the same object. I'm not the same as I was an hour ago. I have, oh, by the way, okay, there is a biologist, yes, he is on this reference list. His name is Umberto Maturana. He was the founder of constructivism. He is still alive in Chile, a biologist. His famous book is Autopoiesis, Structural Coupling and Cognition. So he was the founder of a new philosophical approach called constructivism. And what he says, living systems existed as autonomous totalities in a molecular medium with which they were in recursive molecular interchange. Through this understanding, my claim became that a living system is a dynamic composite entity realized as a unity, as a closed network of production components. So basically what we have a bunch of molecules and atoms from this area, and for some reason they start behave differently. Something happens, there is a cycle of life, I don't have no clue why, but a live system composed of the same elements as this one has this cycle, and that does not. And what Maturana says is that there is constant exchange of atoms from the outside through the surface of our live matter, and our molecules of our body are being replaced all the time. All the cells of our organism are constantly renewed, and each organ has its own period of renewing. For the skin, the fastest is the outside layer of our skin. It is renewed every 2-3 weeks. Deeper in our body, it's not as fast, but within 60-80 days, my skin is renewed completely. So if I come back in 2 months, there will not be a single atom in my body on top, which is here now. For me, it's so my atomic structure. Well, the longest time takes this bones, 10 years. So within 10 years from now, it will be completely different components, and that it's still me. So we cannot say that about the ball. The same atoms stay there all the time. That's what we think. But here it's proven, here with a live object, we are completely renewed within a certain period of time. That's what is interesting. Now, if we come to the laws that, for example, there is a lot of carbon, hydrogen, oxygen, some other elements. If we put them into a container and radiate it with some kind of wave and register what goes out, there will be one thing. If I decompose well, some animal up to the basic elements it consists of and put it into the container, so there will be one thing. But if I do not decompose, I just put a live tiger and radiate something through them, register on that, there will be a different outcome. So the same chemical elements organized as a living organism behave differently as opposed to the same elements not organized as a living organism. So people emit certain kind of radiation, different people, different kinds. There are a lot of speculations, a lot of myths, a lot of false news there too. But the fact is, there is difference. Even if I say I take the same components I have here, but not organized as a live matter, it will be one result with going through some radiation. With a live matter, it will be different. Well, it depends on what kind of frequency, probably. I'm not sure about details, but that has been registered. So that means that physical laws for the same atoms here are not the same as organized within organism. What else is different? So if we have our regular object, so it's solid eternal, and for us it doesn't matter where it is, the sun, the earth, outside, outer space, or at the bottom of the ocean. So it will be affected some way. We can register that, we can correct it. With life, there is a certain range of temperature, gravity, air, and other stuff where it can exist. It is wide, but anyway, there is a range certain within which it can exist. Well, at least I would say certain forms of life. There might be some exceptions. I don't know about them. Now, on top of that, alive objects consume or exist only because they consume other live objects. There are some exceptions, probably, that like live with sun radiation or something like that, and air, but generally one organism cannot exist without other organisms. That actually brought an idea that all the species of life, all the varieties of life exist as one big system. They cannot exist without one without the other. If they cannot, they are connected in some way, so logically speaking. So there is some system which brought up the idea of noosphere, or noosphere. And at some point we'll talk about that, and there is a lot of definitions with it. And then yes, when we are talking about a representative of a living organism, we are taking the best. So if we discuss the cows, we go to a farm and they will show, okay, this is the regular cow. So, and we are talking about the best species we have. So normally, this is how it is. On all the exhibitions, the horses, other animals.
So we're not looking
Yeah.
for the average, is what you're saying.
Yes.
We're not looking for the sick cows, we're not looking for the young cows or the old cows.
So, yes.
We're looking for.
Oh, that way. Anyway, I believe there is a difference in approaching to bring up the sample of the species. With dead matter, it would be an average ball. With a cow, we'll be thinking of a best cow. Like, I'm not in agriculture at all, so yes, please.
In biology, I think this is maybe something that you're alluding to. We have particular samples that we look for. Like for example, if we're trying to study plants, and we have an idea as to which plant would be best for a certain study, and we don't go looking around for sick plants or deformity plants, or we look for a particular type of wild type. Even if we consider it an average, our theories, our observation is theory-laden. We go for particular plants for particular agricultural studies. So maybe along those lines, we don't go for just a general cosmic average, like in astronomy would look for a plant.
Right.
Yeah, thank you,
I
Peter.
think that's what I was getting at.
Yeah. But anyway, with all the exceptions, when we come to the human and human society, and we are talking about a sample of human organization, that would be the only option we have. So when, like Marx wrote The Capital, he was thinking of an ideal, best organized capitalist society he could think of to make a model, which probably doesn't have like cannot be related to any exact society of his life, but talking about a model, a sample in social world, we'll be talking about this normally. Anyway, all this stuff, with all these things, it inevitably comes to the idea that something has to change in the ways we use our thinking. Um, well, Mr. Hegel. So he used to tell scientists, start thinking about mind, start thinking about consciousness. So normally scientists do not know how they come with models, how the process works. It's not the scientific way of approaching business. And he said, you have to study the way your mind works in order to proceed with your scientific research. But I believe this is what we have to do in order to understand how to think properly about society. So we have to look back at our intellectual tools. He also said that normally, like, we don't question that, but only well-educated people can stop and question the obvious. So something that we never questions, that comes without any questions, it is possible to question that only if you already thought a lot, consumed a lot, that allows you like the freedom to look back and say, am I fool here? How stupid I am. And that's the only way to go through the hypnosis of that scientific pattern, break through, and find how to consciously use these tools. Okay, and one more. Well, some kind of review here too. So looking back at what we thought about all this thinking in terms of tools, thinking tools. So first of all, we consider a cluster of ideas, concepts, and approaches. So it's not one approach, it's not one view, it's not one projection. We have to consider all that is possible when we are looking at an object. So that is a composite view, including those that are not scientific by any definition. I would say theological, religious, mystic, pagan, whatever else we can think of, what we know about. If we are talking about society or life and people, it has to be taken into consideration some this way or another. Another one is that we use a reflection as a tool of thinking on and off. One more thing about science and non-science. So scientific view, I think I wrote that scientific reasoning is object-oriented, and since we do not question our intellectual tools, the object commands us how and what to think about that. So we know something about metal, and the ways we used to think about metal, we start analyzing and thinking about that without questioning why and how we use it. And if we then analyze what we did, so our tools are made like to suit the material, the makeup of the object we are talking about. And that way, science is a certain system of knowledges that is related to a rigid object structure. So we have an object, we structure it in this or that way, and we have knowledges that are structured in a similar way, and one component is viewed by one, another one. So we know chemistry, we know like pure mechanics, velocity, acceleration. So there's one type of knowledge. It relates to one part of our object. Another type of knowledge tells us about another component. These knowledges are interrelated. They're somehow kind of linked within each other, well, similar to what components do. So this relation between the object and the knowledges, and both are structured. So this is a model of scientific thinking. With that reflection part, this is a philosophical type of thinking. So reflection is kind of goes into deep, and it also questions how I think, what are the tools that I'm using, why, on what basis, why I use this or that axiom. So when I start questioning all this, this is called a classical philosophical approach. Basically, the trick is to combine the rigid structure of the knowledge we have that is linked strictly to the structure of the object, and the reflectional part that questions the thinking tools that we have. Well, this approach that combines both was called methodology. Methodology, and was practiced by that Moscow Methodological Circle. Just a couple lines about this circle. It started approximately about 1950 as a seminar of philosophical department of the Moscow University. One of the founders was Alexander Zinoviev. He is a world-known logician. He wrote, and he is one of the founders of the multi-valued logics. Then he wrote a couple pamphlets on the Soviet society, and went into immigration in the 70s. He lived in Germany, and he wrote a couple more books about Soviet Union. In 90s he came back, and when he was young, in 1930, he was plotting to kill Stalin. So he found a couple friends, they decided, okay, we want to kill Stalin. They were looking to buy a gun to come to the parade on the Red Square on the 1st of May and to actually do the assassination. That plot was discovered. So his friend got arrested. He escaped, went to the country, kind of got lost without papers, without nothing. Then the Second World War started. He was into the military, so he was a soldier, and then he came back and everything was forgotten. Nobody remembered that, and he finished Moscow University and became one of the famous logicians. So then he criticized the Soviet, well, he got a lot of bonuses as a scientist, but then he started openly criticize Communist Party, so he had to go to Germany. When he came back, he was one of the most open critics of Perestroika and Gorbachev, and proclaimed that Stalin was one of the best leaders of the Soviet Union, and he completely changed his political views. He was one of the best defenders, and he died about 3 years ago. But anyway, so he was one of the founders of that circle. Then there was a guy with a name. So these 4 letters, TSCH, goes the little sh, like soft sh, not sh but sh. Shchedrovitsky Georgy Petrovich, his son is Peter, he is now alive. Shchedrovitsky died in 1980 something, I forgot the date. But through all his life, Shchedrovitsky was the leader of the circle, and until his death, about 500 scientists from all sciences went through that circle, and they were of physics, mathematics, psychology, pedagogy, sports, other stuff, and they've been discussing intellectual tools and how they apply to science and how to use that. So I'm just repeating the ideas about science and philosophy. And my best defense that they are good is that it went through 40 years of discussing among very smart people with that big number. So that means that the whole idea went through a very nice, good filter of looking at that from various points of view. Now, most of the clocks in the Kremlin are followers of that Shchedrovitsky. But Shchedrovitsky did not go into consciousness. So they discussed only reflection and collective or team thinking. They didn't go into consciousness on purpose, thinking that if they do any research on consciousness, the Communist Party can grab the results and use it against the people. So that way was their political view and the explanation why they didn't do that. But what they did, they looked through most of the philosophical thought before them about the science, reviewed that, and analyzed as to ways the mind works. So that I'm using it right now. Well, now that we have some idea of what science is, so I'm talking about the science that deals with macro objects that are solid, eternal, and independent. And science been using formal logic, modeling, theories. Well, this stuff is important too. And these are the tools that we are using and we want to use. So for me, science would be, again, a set of knowledges used to describe a structure of some object, using formal logic, formulas, models, and experiments. I would love to be able to use these tools when talking about other types of objects. But these other types of objects are different in a way, and we have to look deeper into the origin of our consciousness and the origin of society as a structure. So my plan is this. So based now on this kind of tools, we have to look into these topics. That would be origin of consciousness. So just from bottom up, organism starts, how it becomes conscious, and what are the mechanisms it uses. After we found some consciousness, how speech works. So we use it consciously to some extent. So it's speech, a language, and all these mechanisms. And now, based on how we process the facts about our life, using the speech, what does that bring? We can come to the structure of society. Okay, social structure. And there, as a part of it, will be the theory of governing of any organization. Governing. Well, I believe that will take, these two topics can come together, and probably these two will come together, so that's at least two instances more. We probably will need something in between just to discuss the questions or concerns you have, because on one hand I might made mistakes like just saying something, or other kind of mistakes, or didn't cover some things that seem obvious to me but not obvious to you, and we have to come together and kind of discuss if we can do that. So I want to stop my recording.